Now we have previously learned about Newton's first law, which was law of inertia, right? Now we are going to see Newton's second law. So Newton's second law states that the change of momentum of a body is proportional to the applied force acting on it, and the change of momentum also takes place in the direction in which the force acts. So two things this law talks about: the force and the direction. So we know that force is a vector quantity, so obviously it will have a direction. Now it talks about the change of momentum. Suppose this is a body, this is at rest 0 meter per second. After that, after a certain time, it runs towards this direction with 5 meter, 5 meter per second. It moves towards in this direction with a velocity of 5 meter per second. The mass of this body is suppose 50 kg. And at this position also mass will obviously not change. Mass does not change. So at this position, what was its momentum? We know that momentum is mv. So this was its initial speed, which was 0. So I can say mu. U as in initial velocity. So mu is the momentum at this stage, and at this after running with 5 meter per second velocity, its momentum is becoming mv. Now what is the change of momentum? Change of momentum is I can write the change of momentum like this: del momentum, or I can write del p, because p is the symbol of momentum. I can write del p is equal to mv minus mu. Okay. Now if I say that from this position to this position it requires 5 seconds. Okay. So it requires 5 seconds. That means t is equal to 5 seconds. Now Newton says that the rate of change of momentum, this is the change of momentum, this is not the rate of change of momentum, this is the change of momentum of a body is proportional to the applied force acting on it. So the boy, when it ran to this position, he had to apply some force within himself. So what was the force? In order to find out that force, we have to find out the rate of change of momentum. We already found out the change of momentum. Now let's find out the rate of change of momentum. Rate of change of momentum. So rate of change of momentum is equal to mv minus mu divided by t. Because whenever we are talking about the rate of change of anything, that means time is involved. With respect to time, we are finding out the change. So rate of change of momentum is equal to mv minus mu, which is the change of momentum, divided by t. That is the rate of change of momentum. Newton says that this thing should be, rate of change of momentum is proportional to the applied force. That means the force that this boy needs to apply within himself to run to this position is proportional to this mv minus mu divided by t. Or I can also say that f is proportional to, taking this m common, because m is obviously common in both cases, because mass for this boy is always be same. It will never change. Mass will not change. So I'll take this m common and write v minus u divided by t. I can write this So what does it mean? This thing means rate of change of velocity. We know the rate of change of velocity is equal to what? Rate of change of velocity. Rate of change of velocity is equal to acceleration. So I can say that force is directly proportional to ma. So this is how the formula of force comes. That we know that force is equal to mass into acceleration. Where does it come from? It comes from this Newton's second law, from this theory that force is directly proportional to mass into acceleration. Now, the unit of force we know as Newton, denoted by N. Dimension of force is ml divided by t square. Why? Dimension of force is ml divided by t square, because force is equal to mass into acceleration. Now, what is the dimension of mass? We know the dimension of mass is m. What is the dimension of A? We know the dimension of A is L T inverse square. So the dimension of force is m L T inverse square. This is m L by t square, or m L by t inverse square is the same thing. So the dimension of force is m L T inverse square. Okay.